Problem number 5, we want to do some trig factoring here. Of course, first step of factoring is always to look for a GCF, and that's what I see in part A. I have a sine x that's in common to both terms, so I can pull that out to the front, leaving me with tangent x minus 3, and that's about all I can do. There's no more factoring that I can do at that point. Part B. I do not see a GCF. That last term is just a 6, so I don't have anything I can pull out. I see 3 terms. When I see 3 terms, I'm thinking this was somebody's FOIL problem. Sine squared x, there's only one way that that could have happened. Sine x times sine x. 6 at the back, let's see, it could be 1 and 6, it could be 2 and 3. Those are interesting choices because I kind of feel like I could make a 5 out of either a 1 and a 6 or a 2 and a 3. This is where I have to think about the signs though, because I need a positive 5, and yet the negative here tells me that one of these numbers must be positive and one must be negative. I don't think I'm going to be able to do that with the 2 and the 3. I would need both of them to be positive, so that's out. I'm going to need to do a positive 6 to make 6 sine x for the outer, and then a minus 1 to make minus 1 sine x for the middle. There's my positive 5 sine x. So it looks like the final answer here then is sine x minus 1 times sine x plus 6. Letter C. I think this one is like part A. I see a GCF. I've got a 2 that's common in both, and I've got a sine x that's common in both. So from the first term, let's see, I took the 2, I took one of the sine x's, so that leaves me with the other 2 sine x's. And then here, 8 divided by 2 is 4, and I took the sine x. So I factored out the GCF. Of course, it's tempting to think you're finished like we were in part A, but now when I look at those 2 terms in my parentheses, I see I've got a difference of squares. I've got a minus sign and 2 perfect squares on either side, so it's going to keep going. It's going to factor in that A plus B, A minus B pattern. The A would be sine x, because sine x times sine x is sine squared x. The B would be 2, because 2 times 2 is 4. And so now I have fully factored this expression. Part D looks like part B. No GCF, so nothing I can do there. I see 3 terms, so I'm going to do a FOIL situation here. The front one looks a little tricky. 8 could be 4 times 2, could be 1 times 8, so I'm not entirely sure. The back part looks easy. It's got to be 1 times 1 to make 1, and in fact, it's a negative 1, so it's got to be that one of them is a positive 1, and one of them is a negative 1, so that's good. I need to make a 2 in the middle. Well, I don't see how I'm going to do that with an 8 and a 1. There's just no way. It's got to come out to be the 4 cosine x and the 2 cosine x. I just got to think about which one to put where. Let's see, I want the middle one to come out to be negative, so I think I'm going to have to put the 4 cosine x here, because what I'm looking at is then the outer multiplication would be negative 4. If I put the 2 cosine x here, then the inner multiplication would be positive 2 cosine x, and that does it. Negative 4 cosine x plus 2 cosine x makes that negative 2 cosine x in the middle that I needed. And so we're done. We factored it. Problem number 6. We want to solve each of these quadratic equations, this time using the square root method. The square root method is perfect when you've only got one letter x showing. And that's what I have in both of these examples. How does it work? Well, in the square root method, you start by isolating the item being squared. In this case, it's x that's being squared. So I'll add 5 to both sides, and then I'll divide both sides by 3. And once the item being squared is isolated, then you just need to undo the squared, which you can do by taking the square root of both sides. Remember, when you square root both sides of an equation, you do get 2 answers. You do get a positive answer and a negative answer. And so here would be the final 2 solutions. X equals positive root 7 and negative root 7, which you can summarize by just writing x equals plus or minus root 7. Letter B should be similar. I'm going to subtract 6 from both sides. Then I'm going to divide both sides by 5. Now this one doesn't come out as nice. I have a fraction over here, 12/5, but the method is still the same. I'm going to square root, plus or minus, remember, at that moment. And then I do have some cleanup to do, right? I'm not going to the calculator on these. I want exact simplified answers. So what will I do? I'll have to split that up into two parts. So I've got the root 12 on the top and the root 5 on the bottom. I can simplify root 12 by pulling out a 2, right? 12 is 4 times 3, and the square root of 4 is 2, so that becomes 2 root 3. I can't simplify the square root of 5, but I'm not supposed to leave square roots on the bottom, so I'll have to do the little rationalize the denominator trick, root 5 over root 5, and I think that should do it. I'm going to get two answers, plus or minus. On the top, I get 2 root 15, and on the bottom, root 5 times root 5 is 5. So plus or minus 2 root 15 over 5. Problem number 7. So we're given a little statement here with two variables in it, x and u. We're then given a value of u and being asked to plug that in and solve for x using algebra. So in our first example, we're going to replace the u with 5 pi over 2 and then do some algebra to get the x by itself. So it looks like the first step would be subtracting pi from both sides. Let's see, 5 pi over 2 minus pi, I might have to do some scratch work on the side. I could rewrite pi as 2 pi over 2 so that I can have that common denominator, right? That's still equal to pi. 5 pi over 2 minus 2 pi over 2 would be 3 pi over 2. So I have 3 pi over 2 equals 2x. To get the x by itself, I would divide both sides by 2, although since I'm dealing with fractions, it would probably be simpler to think of it as multiply both sides by 1/2. That is the same thing as dividing by 2. On this side, the 2's cancel, and here's my final answer then. Just multiply across. I get 3 pi on the top and 4 on the bottom. X equals 3 pi over 4. Similarly, in part B, I've got a simpler equation this time. I'm replacing the u with 3 pi over 4, so that gives me 3 pi over 4 equals pi over 6x. I can get this x by itself in one step. Just multiply by the reciprocal of this number, 6 over pi. On the right side there, that'll leave me with just the x. The pi's go, the 6's go, the x is by itself. On the left, I can do some cleanup. Let's see, do I have any common factors? The pi's divide out, and 4 and 6 share a common factor. And so I believe when everything is finished here, I end up with 3 times 3 is 9 on the top, and I have the 2 on the bottom. X equals 9/2. Finally, for the last one, the u is negative 5 pi over 6, so I'll fill that in. The other side looks a little bit complicated. I've got pi over 4 times x minus 3. I need to get this x by itself. Well, the outermost thing happening on the right side is that pi over 4, so I'll have to address that first. I can get rid of that the same way I did in the last problem. Just multiply both sides here by 4 over pi. And if you do that, on the right side, you're left with just the x minus 3. On the other side, once again, the pi's divide out, and I once again have that common factor of 2 that I can divide out. So I believe I've got negative 10 on the top and 3 on the bottom. And the only thing left to do would be to add 3 to both sides. Again, I might benefit from some scratch work off to the side. Negative 10/3. I could rewrite the number 3 as 9/3. And so after I finish that, I'm going to end up here with negative 1/3 as the final answer for x.